This is everything you need to know to do every reaction in organic chemistry ever. For the purposes of this video, let's say the question asks, for the following reaction, draw all products and the reaction mechanism, including all arrows. If they're nice, they'll say that. Step 1, for every question you do in organic chemistry ever, draw in your electrons, all your lone pairs and all the electrons in the pi bonds. These are the electrons that are going to be moving. Step 2 is on both of the reagents, draw in all charges and or partial charges. Let's start with putting the charges on NaCl. I'm not going to get into it in this video. I'm just going to be short, sweet, and simple. Whenever Na or K potassium is paired with a halogen or a hydrogen, Na will be positive, the other atom will be negative. So there is a positive charge on the sodium and there is a negative charge on the chlorine. For propanone, the case is a little bit different. There's no formal positive or negative charge, but there's an oxygen, and oxygen is electronegative. What does electronegative mean in organic chemistry or in chemistry in general? It means an atom is greedy. What is it greedy for? Electrons. Who does it steal them from? The atom directly connected to it. Hence, the oxygen will have a formal delta minus sign, and the carbon connected to the oxygen, that's electronegative, will hence have a delta plus. Now for the reaction mechanism, all you gotta do is draw the back of the arrow going away from the most electron-rich atom. How you define richness in organic chemistry is an atom with a negative charge is more rich than something with a lone pair, which is more rich than a pi bond or a delta minus atom per se. Rich in real life means you have lots of money. Rich in organic chemistry means you have electrons. Hence, electrons are the driving force of all reactions. In this example, the chlorine is the most electron-rich atom because it has a formal negative charge. Hence, the back of the arrow is drawn going away from it. Then we draw the head of the arrow pointing at the most electropositive atom on the other reagent. So hence on propanone, since the oxygen is electronegative, drawing electrons towards it, that carbon is more electropositive. We draw the head of the arrow pointing at it. So finally, all you gotta do is connect the back of the arrow to the head of the arrow. That is your 2 in. Every 2 in, because you're pushing 2 electrons from the chlorine to the carbon, needs to be reciprocated with a 2 out. Then you ask, okay, what's my 2 out? Oh, there's a pi bond that I drew in both electrons at the beginning connected to the carbon. Hence, one of the pi bonds goes 2 out or 2 up, however you want to look at it, onto the oxygen. So the oxygen gains 2 more electrons. So now, when you draw the product, you have to remember the 2 in arrow formed a new bond. So that arrow you drew is literally a bond in the products. The out arrow took 2 electrons that were in a bond and said, I put you on top of the oxygen. Hence, there's no longer a double bond connected between the C and the O. Those 2 electrons now are on the oxygen. Hence, the oxygen gained 2 electrons and is now negatively charged. That's it, that's all. And then the sodium ion is just floating around, balancing out the negative charge on that oxygen. In a real life example, there would be definitely a workup, but we could do that in another video. So yeah, hopefully this was helpful. Let me know if you have any questions.